Hello and good afternoon, everyone. Thank you for joining acadsystems free online lesson. My name is Nabil Fikri bin Shaizan, and I'm an application engineer on the product design and manufacturing area. For today's topics for the online lesson, I would like to share with you about the Inventor Finite and simulation, or the FEA simulation stress analysis inside of Inventor. So this is some of the basic things that I would like to share with you on how you can use Inventor to do a static stress analysis. And also will show you on the modal analysis. So if you want to see the frequency that will allow vibration on the component. So this is basically some of these things that I will share with you on how you can use Inventor to setups for to allow the analysis to be run. So I will share with you on the Inventor. Right, so this is basically the model of beam that I will use for today's simulation. Right, so basically I have two models. So one is the beam, which is the L shape, and I also have the other one, which is the I beam over here. So so we'll take a look at both of these and see how we can utilize the stress analysis inside of the Inventor. Right. So I will start first on this 3D model over here. Right away on the right side, you can see the simulation for the stress analysis. So you can just click over here and you can just run this analysis for this model over here. So if you don't see this particular simulation ribbon over here, you can go to this drop down and make sure to check on the simulation over here. Now that I have my my model created over here, so you can also apply materials over here if you need to. For my case, so let's say I'm just going to leave it as default. Let's say generic. Now I can just go to the stress analysis over here. So by default, it's already show me some of this stress analysis. So I'm going to delete this one first. So when you start, most likely you will have these empty things that you cannot select over here, except for the case studies. So to start with the stress analysis, you can go into these case studies and select which studies that you want to create. Right? So whether it's the static analysis or the model analysis. So first of all, I will show you the static analysis first. And over here, we also have this checkbox for the eliminate rigid body modes, which I will show you later on. So we start first with this static analysis first. Right. Press OK. And it will show you some of the things that you can input the setup over here. Right. So we have the materials, so we have the constraint, load, contact, mesh, and lastly, which is the result setup that we need. So which we can use from over here. So first of all, I'm going to input the materials. So I can just click assign over here. So if you already assign the materials over here on the originals, so you can just simply select OK. But if you don't apply the materials yet, you can go to the override materials. Here you can select the materials that you want to use for this analysis. For example, I'm going to choose, let's say, mild steel. So steel mild. I'm going to press OK. So it will show me here the materials already been set up. Then I'm going to apply for the next one, which is this constraint. So the constraint is where you want to say which of this area which is connected to other parts, or what you can say it will not be moved. Right? So which means you constrain this particular area. Right? For example, if this beam mounted to the wall, so you can use constraint fix and select some of the area which will be mounted to the wall. Right? For this case, this beam will be mounted or connected, bolted on the other beam members. So for example, on this particular faces over here, including these two. So I'm going to choose fixed constraint. Right. So you can see over here we also have other constraints such as spin or frictionless. Right. For example, if you want this one to be put on the ground, for example, you don't want to bolt it on the ground or glued to the ground, so you can use frictionless. Or if it has some sort of hole that you will be connected using pin, so you can use pin. Right. But for this case, this one will be bolted on other beams. So I will use fix, which means this one will not be affected by any force or loads. Right. So fix, we use these two areas and the other two on the other side. Okay. Right. And press OK. So this particular area will not be affected because it's already being bolted by using the fixed constraint. You see, I have fixed constraint. Highlight over here. So next thing is it will ask me to apply the loads. So the loads you can find over here. So you have some of the loads. So I will use force, and I'm going to apply the magnitudes of, for example, I'm going to put around 200 kg of loads on top of this. So on Newton, it will be 2000 Newton, and apply on this area. So you can see it show me the arrow that which indicate the direction. So if you want to change the directions, first of all, you can just flip the direction over here. Or if you want to have the direction on other angle, for example, on the z-axis or the x-axis, so you can also turn on the vector component. Right? So if you don't see it, you can just simply drop down over here and check on the use vector. So by default, it has already applied on the y direction, which is this. You need to other directions such as the x, right? So you can just simply import from here. I'm going to uncheck this one, so because this is the direction already correct. And I'm going to press OK. So we have our load applied over here. So next we have contacts, but for this case, we only have one body parts over here. So if you have multiple body parts or assembly, so you can use contact, which indicate the contact between two parts. So since we only have one part, so the contact here we can ignore for now. So next thing, the last thing we need to do before we can run the simulation, which is this mesh view. Right. So if you press the mesh view, by default, it will give you the default mesh pattern over here. So you can see this triangle over here. So this will be used to calculate the face over here. Right? So it will use this triangle over here and try to calculate the vector and the analysis on all of this mesh over here. So the more mesh that you have, the more accurate result that you will get. So to make more mesh, so you can try to go over here, and on this setting, on the mesh setting over here, you can try to reduce the mesh size over here. For example, I want to reduce to 0.04, and then I press OK. And then over here, it will show me this flash arrow over here, which I can right click to update this mesh. And it will show me the new mesh pattern over here. So you can see it is now much smaller, right? So which means the result I will get will be much more precise. However, when I try to run the simulation, it will be much slower compared to bigger mesh, right? So you can try to select the required mesh for your PC. Right. So the mesh has already been applied. So the last thing, I can just simply click the simulation to run, and it will run the simulation for me. Right. So right. So over here, I already have the result here. Now, most likely for the vortices or the stress over here, it does make much sense because we need to compare to the material allowable stress over here. So we're going to skip first on the stress and go directly on this displacement result over here. So this is most likely that you want to see which is the area that has been bent or deformed, right? So on the displacement area over here, how we can see the result or how we can read the result, it shows you over here. So you can see this particular table over here show you the minimum and the maximum area of the deformation happen. Right, so you can see the largest deformation happen is actually around 0.1 millimeter. Right. So you can see the deformation is actually quite large over here, but the result over here is only 0.1 millimeters, is actually quite small. So the reason why you see this is because the display show you an exaggerated result. Right, so you can also control or adjust it from here. So if you want to see undeformed, so you can select undeformed, and you can see it is not deformed or anything. So on default, it gives you ×1, right, which have this particular result. Now, the actual one that changed is actually on the actual. So you can see almost no change from the, oh, sorry. Okay, so, okay. Right. So the one that has not changed, which is the undeformed over here, and the one is the actual changes is on the actual over here. So on the actual, it's only 0.1, so you barely see the change. Only if you go zoom, then you can see it is actually 0.1 millimeter change. So this is the actual. If you don't want to see the deformation actually, so you can just select undeformed, so it will show you the original result. So you want to see much clearer, so you can select on this adjusted result over here. So the reason why it gives you the adjusted ×1 is because on the actual one, sometimes it's very hard to see on this direction for this bend actually happen. So that's why it gives you the actual. Now, other thing is you can also see based on the color. So the higher the red color here, which means the higher the deformation actually happen on that particular area. Right, so basically it's around here. So if you want to see the exact location, which is the millimeter of displacement happen, so you can go to display over here and turn on the minimum or the maximum. So minimum, basically no change happen. So there's maximum, which is this particular area. Now, if you want to see manually, for example, this particular area, how much the deformation happen, so you can go to the result and use the probe and select on this particular area, and will show you on this particular area the deformation happen around 0.05 millimeters. So that is the displacement. So the other things that you can see from here is also safety factor. So you can just double click on the safety factor, so you can see how safe this object actually is. So you can see the highest safety factor is around 15, right? So 15, the maximum. So the only minimum safety factor is 13. So most likely the required safety factor, the minimum should be around 2.5. So this one is already safe. But however, if you want to see which is the minimum safety factor, so you can also zoom in over here and see. Make sure to turn this one off on. Sorry. So you can turn this one on, so you can see much clearer on this location. However, the deformation actually still quite hard to see. Is because all of this color is indicated blue. It's because the safety factor is very high. So if you want to filter out just to see clearer the location for the safety factor value, so you can also toggle on the color bar over here, and you can control. Let's say I want to filter out from 15 to the minimum only around 13. So it's try to filter out, will only show you around this area, so you can see much clearer on this red one over here. So if I try to zoom on this particular area, so you can see much clearer over here. Compared to if I just use minimum over here, 0. So you barely see at all. So you can also toggle or filter out based on the value. So let's say you just only want to see which is the minimum only. So you just enter this value manually over here. Now, okay, so that is on the displacement, also the safety factor. So let's say if you still want to read on, so let's say you still want to read the stress value over here. So you can see the maximum stress value is around 40.97 megapascals. So you can see it is highlighted over here. So the most stress one will be the higher stress that occur. So by the value itself, it actually holds no meaning. So you need to compare the value over here to the material's allowable stress, right? So whether it's yield or the tensors. So to compare that, so you can see that our material that I applied over here is the steel mount, right? So mild steel. So you can go back on this material over here. So select this one, and it will show you the list of materials. So find the correct material that you have applied over here. So we have steel mount, and you can see the editor over here, which will show you the physical properties of this strength analysis. Supposedly, it will show you the value over here. For example, but for some reason it does not show because it is actually created as copy. So I needed to clear all of this one first. So let me try select the generate value over here. Right, so I just clear this one out, and I needed to delete this one, and delete this one. So clear everything, and can go back to my schema over here and select this one. So this one will add materials which will allow you to edit. So reason why it does not show before is because it's trying to create a copy because we already have that one. Right, so that's why I delete everything. So it will come as fresh. So you can see this is the default value or the minimum value for the strength, minimum or the maximum. Right? Value for the maximum value for this yield strength and also the tensile strength for the stress. So as long as your stress value does not exceed this particular value, so your result should actually still safe, right? So just if you want to compare, so you can just compare to the material on this physical over here, right? On this strength over here. So we have yield strength, also tensile strength that you can compare with the value that you have, with the value that you have on the result. Right? So you can see it is actually still very low. Now that is the sample for the basic stress static analysis. Now, which is this one we bolted on the other beam, but what in case that you just simply put this beam on the ground and you want to stack the other beam on top of this? So you don't want this particular beam to bend when you try to stack this particular beam, right? So you want to do some analysis over here. So right. So for example, I already created this constraint over here. So this one will not be bolted on other beams because I put this beam on the ground. So I'm going to delete this constraint, and I'm going to put frictionless. So basically, this one can be moved on other sides, right? It can still be moved, but this one actually put on the ground. So I will put over here the frictionless constraint. Right? So basically, I put this on the ground. Because this is frictionless constraint, so when I press OK and I try to simulate back, so it will say to me that this is not enough constraint, because for the normal static analysis, it will require you to put this particular object on static, which means it should not be able to move. Now, to do that, I can create a new studies. For this one, I won't allow it to detect and eliminate rigid body models. So it will add me the soft springs capability on this particular object. Right. So since I already applied some of these things, so I can just simply right click and edit from here and just simply on this detect and eliminate rigid bodies. Right, so if you want to create new, you can also go over here and create new that you can select from here. I believe I have select already, so the constraint already been applied, and the static also allow the eliminate rigid body modes. The mesh already been applied, so I just need to simulate from here. So I just simulate, so you can see it is now able to simulate this analysis. Now you can see, so the deformation actually have different types of deformation. So let me select adjust from say 0.5. So you can see it is actually deformed a little bit on this side also, right? Not just on the bottom side. Right, so you can see the displacement also change the displacement value. It is actually much higher, so it is not recommend to put on the ground unless the force that you apply are not actually that big. Right, so this is basically some of the things that you can do. For example, if you need to change the object, for example, if I needed to make this one much thicker, so I can just simply select finish analysis, and I can just select this value and make this one thickness, right? Or maybe I want to select other types of beam. For example, this one I use, for example, this right. So the one that I use over here, which is the L beam. So I want to use the I beam like here. Right. So if I go back over here, state analysis over here, I can right click back on the study properties and go to the model over here. Right, so, and here I can choose the correct one. For example, I need to use I-beam. Right, so when I press OK, all I need to do is that I needed to right click on the mesh and just update back the mesh. So everything, all of the settings, you can just leave it as default. Right, and just simply run the simulation. So you can see the different value actually occur on the different types of shape or the thickness that you have created over here. Right, so this is basically static analysis. The other analysis that you can do, which is the modal analysis, which will happen, which will vibrate violently on certain types of frequency. So you want to see which type of frequency that your vibration actually happen. So from here, there are multiple settings that we can apply. For example, if you want to see more result, you can control from the number of model over here. Let's say I'm going to put it around 10 result. I'm going to press OK. So for here, you only need to apply materials, constraints, and mesh only. Right. So if you have context, so do apply that one, this one as well. For the load, so you can just simply skip the load. So I'm going to go ahead and assign my materials. So again, I'm going to use the same materials, which is the mild steel. And this will be the constraint. So this constraint to the other beam. So for the load, I don't need to apply the loads, and just skip to the mesh settings. Right? And I can just simply run the simulate, and it will show you the result of the frequency that will happen, the vibration that happened on certain type of frequency. Right? So on the 86 frequency, so this particular area, it will show you. This particular frequency, this vibration will occur, right? So on this frequency, right? So on 123 hertz of frequency, this direction, the vibration happen, right? So to ensure that the vibration occur less, right? So you might want the frequency to be higher, right? So you can also go back like before and edit back For example, let's say you want to edit back the thickness of this. So the frequency will likely to be much more higher or leaden to occur. For example, use, say, after taking this one about, let's say, 1 millimeter. We select the face. See, so that one has been taken, and this one as well. So I have taken my object here. So I go back to my stress analysis, and it will show me the update arrow over here. So I can just simply right click and update the mesh and just rerun back the simulation. So you can see, so let me see. So not much change actually happened over here. So maybe I needed to be more thicker than before. So only then the frequency value will be much higher. Right. So that is basically all that I would like to share with you about the stress analysis or the finite element simulation inside of Inventor. Right. So thank you again, everyone, for joining our film lesson for today. So before I end, so I would like to share with you about our website. Right. For example, if you needed to visit us, so you can go to our website. You type in. So you just only need to type acadsystems.com and press enter, and it will automatically lead you to this acadsystems main landing page over here. So if you need it to contact us, so you can see our number over here. So we have KL and also PNA number. Right, so we have 2 branch. So if you scroll down over here, so we also have other promotions that you can find over here. For example, we have medical training promotion, right? So around 50% discount for the training. So if you interested, so you can pick up a call, or you can just go into our website and try to see over here. Right? On the lower here, we have our weekly event, such as the film license, license. Right? So if you're interested on other film license, so you can find it from here. Now, if you needed to see our recording for our free lesson just now, so you can go to our YouTube channels. So we store so we keep our video of this live on our YouTube channel. Right? So you can just find on the bottom of here, it will lead you to our acadsystems YouTube channel. Now, if you have any question, or let's say you have any problems regarding your software, or maybe you need support from us to install AutoCAD or Inventor, so to request help from us, so you can go to our helpdesk system. So from our mailing page, so go over here and go to acadsystems new helpdesk. Over here, you can sign in, or you can also so let me see. So you can either sign in, or you can also sign in as a guest. Right? So if you don't have account, so you can also sign in as a guest. Right. So when you go into the acadsystems new helpdesk, so you should see something like this. Right. So you can continue as a guest, and you can fill out any of your information. For example, your name, the description of your problems. For example, you need some supports. Your AutoCAD cannot be open or anything, so you can just search from here, and you can say the description of your problem, or the support that you need from us, and fill in some of this information from here. Right? So after that, you just simply submit the ticket. So our available support team member will assist you immediately. Right, so that is basically all from me that I would like to share with you. So thank you everyone for joining our free lesson for today. And I hope I can see you guys again on our next free lesson. So thank you everyone. Have a nice day, and bye-bye.